right? From yesterday, we talked about end behaviors, multiplicity, finding the zeros. You guys are going to have a quiz on Friday, right? It's going to be multiple choice. We just decided to do 12 multiple choice, but it's very straightforward. If it says find the zeros using the whatever, that's the P over Q. Remainder theorem, what do they care about? The remainder, right? If it says synthetic division, long division, it's multiple choice. Do what you need to do, but make sure you know how to do all the different pieces. Work tonight on any practice that you guys have, and then tomorrow in class, I'll go over exactly what you need to be familiar with. But if we look at a problem like this is the last two from yesterday. If we look at a problem like this, let's talk about the end behaviors of this graph. How do we determine end behaviors? Remind me again, where do I look? The highest, not necessarily the first, but the highest. What is your highest exponent? 3. What kind of a number is 3? So I think odd and opposite. Okay, the directions of the arrows are going in opposite directions. What else do we notice? The leading coefficient is negative. So the ends are going to resemble a negative line. There's going to be bumps and stuff in the middle, but the ends are going to resemble a negative line. So from left to right, what are your end behaviors? It's rising on the left and what on the right? Falling on the right. Good. All right, those are the end behaviors of the graph. How many zeros, how many answers are in this graph? There's 3. Why do I know there's 3? The highest exponent is 3. Do we know if they're all real or anything like that? No. So let's go ahead and look at this. I have 4 terms. Can I group it? No, it's not. You can't. It won't mathematically work. So if nothing works, what did we do yesterday? P over Q, the rational root, P over Q. It's plus minus the last number, which is 2 over plus minus the first number, which is 1. This is pretty simple. I don't have a ton of factors I have to use, right? So I have plus or minus 1 or 2. So now what do? What's the process? Synthetic division. I'm going to start with 1. If I get a remainder of 0, what does that tell me? That it's a factor. It works. So what are my coefficients, guys? Negative 1, 2. What is it? 9 and 2. Okay, so 9 and 2. When we synthetically divide, we bring down the first term, which is negative 1, and multiply to the corner. Negative 1 times 1, negative 1. 2 and negative 1 is 1. 1 times 1 is 1. What's 1 plus 9? 10. Is this going to give me 0 as a remainder? No. 10 times 1 is 10. This gives me 12. Okay, this doesn't work, so I know 1 is not a factor. What about negative 1? So negative 1, 2, 9, and 2. What's negative 1 times negative 1? Positive 1. 2 plus 1 is 3. 3 times negative 1, negative 3. 9 minus 3. Is this one going to work? No, so go ahead and stop. If you realize, wait, I'm not going to get 0 as a remainder, go ahead and go to the next one. So what should we try now? Let's try 2. So negative 1, 2, 9, and 2. Bring down that negative 1. Negative 1 times 2, negative 2. Negative 2 and 2 is 0. 0 and 2 times 2 is 0. 9 plus 0 is 9. Is this going to work? No? Okay. Now what else can we try? Negative 2. All right, so negative 1, 2, 9, and 2. Bring down that negative 1. What's negative 1 times negative 2? 2. What is 2 times 2? Sorry, 2 plus 2. 4. What's 4 times negative 2? Negative 8. What's 9 plus negative 8? 1. What's 1 times negative 2? What's 2 minus 2 or 2 plus negative 2? Oh, thank goodness. What did we just figure out? Negative 2 is an answer. It's an x-intercept. It's a 0. It's a solution. So I know that one of my answers is x equals negative 2. Now, I started off with a cubic function. What do I have left over? What is represented here? X squared. Whoops. I hear you. X squared. X constant remainder. So I have negative x squared plus 4x plus 1 equals what? 0. This is a quadratic. We've done these 52,000 times. What are my 3 options with a quadratic? I first try to factor. If that doesn't work, what are the other 2 options? Quadratic formula or completing the square. What do we want to do? It's not going to factor. So let's do the quadratic. I have negative b, negative 4, plus or minus the square root of 4 squared minus what? B squared minus 4 times a is negative 1 times c is positive 1 all over 2 times negative 1. You guys with me? So negative 4 plus or minus the square root. What's 4 squared? 16. And negative 4 times 1 is? What's negative 4 times negative 1 times 1, guys? Plus 4 all over negative 2. Okay. So you have negative 4 plus minus square root of what? 20 over. What do we notice here? Can we simplify 20? What is 20 simplify to? 4 and 5. So I can rewrite this as negative 4 plus or minus 2 square root of 5 over negative 2, right? If you can't see this, guys, write it out. Negative 4 over negative 2 plus or minus 2 square root of 5 over 2. What's negative 4 divided by negative 2? 2. And then since this is a plus or minus, you don't have to worry about that negative there. But then I have the square root of what? No, those cancel. So just square root of 5. Are those two different answers? Yeah, it's 2 plus square root of 5. And it's 2 minus the square root of 5. So are those my other two values? Yes, absolutely. Are they real? Yes. Are they beautiful? No, but they are real. So you have each one of these. I have x equals negative 2. Let's talk about this. X equals 2 plus the square root of 5. And x equals 2 minus the square root of 5. Do you have multiplicity? You have the same answer more than one time. No. I have each one time. So what happens at the x-axis at all three of these? It crosses through. When does it bounce, guys? Multiplicity, how? Same answer, not just more than once. Same answer, how many times? Okay, what kind of number is 2? Even. It has to, if there's an even number of multiplicity. If you have the same answer 3 times, what happens at the x-axis? It goes through. If you have even number of multiplicity, you have the same answer twice. You have the same answer 4 times. You have the same answer 6 times. That's when it bounces. If it's 1 time, you have the same one 3 times. That's when it goes through. All right, let's do the next one. I'll let you guys go. Whoa. Holy moly. I didn't even look at this problem yet. All right, guys, end behaviors. Odd or even? Okay. Is it going to resemble a positive line or a negative one? Positive. So what are my end behaviors? Falling on the left and rising on the right. Good job. If you had to pick a graph, that should be super easy for you to pick out. Now, how many answers are we looking for? 5. All right, there's 5 answers here. Do you guys, can you traditionally graph it? Factor this? No. So what do we have to do? No, P over Q, your rational root theorem. What's my P value? 45. What's my Q? Just 1. All right, so I have to list out all the factors of 45. 1, 2, no, 3, yes, 4, 5, 6, 7, 8, 9, yes. What's the next one? Then what? 45, right? There's a lot there, guys. What should you probably start with? Probably start with 1. All right, let's start with 1. So list out your coefficients. 1, 5, 8, 16, 15, and negative 45. All right, good, thank you. All right, let's go through this kind of quick. 1 times 1 is, 5 plus 1 is, 6 times 1 is, 8 plus 6 is 14 plus 1. 16 and 14. 30 times 1. 15 and 30. Holy moly. 45 times 1. Wow, that was lucky. So what do we figure out here? That works. X equals 1. This graph is going to cross the x-axis at least one time. Where? At x equals 1. All right, so I started off with x to the 5th. What do I have left here? X to the 4th, x cubed, x squared, x, constant, remainder. So I rewrite my polynomials. X to the 4th plus 6x cubed plus 14x squared plus 30x plus 45 equals 0. Do we know how to factor that? No. So what do we have to do again? We got to do P over Q. We have to do our rational root. And again, we're going to do the factors of 45. So plus minus 1, 3, 5, 9, 15, 45. Start off with 1 again. What happens if we get 1 and it works? Multiplicity. Good. All right, so I have my coefficients this time are 1, 6, 14, 30, and 45. So bring down your 1. 1 times 1 is 1. 6 plus 1 is 7. 7 times 1 is 7. 14 and 7 is 21. 21 times 1 is 21. 30, is this going to give me a 0 as a remainder? No, go ahead and stop. Don't waste your time. Let's try negative 1. So 1, 6, 14, 30, 45. I told you guys yesterday, after you did this a bunch, you get to where it's pretty fluid. Bring down your 1. 1 times negative 1, negative 1. 6 and negative 1 is 5. 5 and negative 1 is negative 5. 14 and negative 5, 9. 9 times negative 1. 30 minus 9. Is this going to work? Okay, scratch it. Go to 3. 1, 6, 14, 30, 45. 1 times 3, 3. 6 plus 3 is 9. 9 times 3 is 27. 14 and 27, 41. Is this going to give me a remainder of 0, guys? No, so skip it. 1, 6, 14, 30, 45. Bring down your 1. 1 times negative 3. 6 and negative 3. 3. 3 times negative 3. Negative 9. 14 plus the negative 9. 5 times negative 3. Negative 15. 30 and negative 15. 15. What's 15 times negative 3? Negative 45. That gives me a remainder of 0. So what did I just figure out there? X equals negative 3. Okay, there's another one. How many total do I need? I need a total of 5. And I only found 2. Oy, oy, oy. All right, what's left over here? X cubed. I love it. X squared. X constant remainder. So I have x cubed plus 3x squared plus 15. Sorry, I'm looking ahead. Plus 5x plus 15 equals 0. Can we do synthetic division again? Yeah, if you guys are in the groove, you're like, oh, I want to do it again. Now you would use it with factors of 15. But when we get to where we have 4 terms and the highest exponent is cubed, try to see if it'll group. If you get to a quadratic, see if it'll factor. That'll make your life easier. Can you group this? Yes, what can I take out of x cubed and 3x squared? X squared, then I'm left with x plus 3. What can I take out of 5x and a 15? Plus 5. So I'm left with x plus 3, right? What's my new GCF? What do I have the same parenthesis of twice? X plus 3, good. I write that out in front once, and then the leftovers get their own parenthesis. So when I solve this, I get x equals what? Negative 3. That's another real solution. Now here when I solve, I get x squared equals negative 5 to where I do what? Take the square root. I get x equals plus or minus I square root of 5. Do I have all 5 of my answers? Yes. Okay, let me write them out so you guys can see them. I have x equals, what was it, 1? 1. Then what? Negative 3. What was another one that we got? Oh, -3. Okay. And then what? Plus or minus I square root of 5. Guys, why are we chatting? Come on. All right, let's talk about these. What are these three? They are real. These actually touch the x-axis, correct? What are these two? These are imaginary. Do these touch the x-axis? No. Okay, good. Yeah.
For the quiz, do you need to include the imaginary numbers in your answer?
It's all going to be multiple choice. So you'll see. Okay, look, guys, we're almost done. I need you to stop talking for 1 minute. I want to talk about these two answers versus this one answer. Those are real, correct? Do you have multiplicity? Yes, where? You have multiplicity here at -3. How many times do you have -3? Twice. That's an even amount of times. So what's going to happen at the x-axis at -3? It's going to bounce, or we call touch and turn. You might see it either way. You have a touch and turn when you have an even multiplicity. Not just any multiplicity, an even one. Oh, I spelled it wrong. You know what I mean. If you have the same answer 3 times, it's odd. It's going to go through. But what's going to happen right here at x equals 1? It's going to cross where? It's going to cross through because you only have it one time. When you have even multiplicity, when you have the same answer twice, the same answer 4 times, the same answer 6 times, it's going to touch and turn or bounce at the x-axis. We are going to work on graphing when we get back from Thanksgiving. You guys are going to have to graph by hand without your calculator, and then you're going to learn how to graph with your calculator. We're going to spend the first 2 days back practicing that. You need to make sure you have your calculator here, and you need to make sure you are here, both mentally and physically. It's hard for me. I'll record, but it's hard. I can't screen record like my calculator, so you can't see like what I'm doing. So it's important. But just make sure that you guys understand, if you can't traditionally factor, what do we end up doing? P over Q. That's your rational root. Remainder theorem. What's the only thing they care about? The remainder. Make sure we know how to do long division. Make sure you understand what happens at the x-axis if you have even multiplicity versus odd multiplicity. Work on the review, and then tomorrow I will go over exactly what you need to know to prepare you for your quiz on Friday. Good? Okay, if we're going to graph this, it's going to be a real rough graph here. All right, so what were our end behaviors? The very beginning, what did we say the end behaviors were? Falling on the left, so your arrows are going down here, and rising on the right, okay? Now, where are my intercepts? -3, 1, 2, 3. So -3 here, and then at 1, right? Yes? And then where is my y-intercept? At -45, okay. So it's like down here, right? To get a quick picture. I wrote my arrows in the wrong spot, guys. So tell me. Falling left and rising on the right. Okay, so Geraldine, are you with me? Okay, guys, watch. What happens at -3? It bounces, and what happens at 1? So watch, we're going to start here, and we're going to go up to -3. Do we go through it? No, boop, we bounce off. We go down here to my y-intercept, and then we come back up, and what do we do at 1? We go through it, and then there we are. This is what your bounce looks like. And then this is what the through looks like. Does that make sense? Yeah, sometimes it's easier to pick. And then, guys, we talked yesterday about how do you know how many bumps there are? It's the highest exponent minus 1. So if my highest exponent here is 5, you would think it should have how many bumps? 4. But what do we know about 2 of our solutions? They're imaginary. So there's more bumps in here. They're just not near the x-axis. But for us, if you're graphing by hand, this is what you would do. You wouldn't get points off because you're showing action at the x-axis. On your calculator, it probably looks like something like this. It's got a little extra. You'll see. You'll see. It's kind of fun.